C# script for my Starship little shooter asteroid game. We have to go over what a pattern is. So a pattern is just a quick fix or a line of code that it's typically what you would use to fix a normal problem. A singleton pattern is what we're going to do, so there can only be one instance for uh, that specific variable. So like we can see here, we have a static, which means it's the only one. It's gonna be awake, and it's not gonna allow for any further duplicates of the singleton. So it's only gonna have one by itself. So when we can see here, this instant does not equal to null, so it's checking to make sure that there's no more game objects, name, game manager, that's static. If it has one, it'll destroy another game object, so it prevents duplicate game managers from existing in there. So this is how we create like a singleton. It's a single use of a pattern. Pros would be using this for like a small game of what I'm doing. It doesn't go over the scope of, if I try to expand this game into a lot of things, it's probably not the best singleton use. But if I keep it on a small scale, it's able to be referenced quite easily. It's global, so all my different classes can use this as a reference. Because you can see here, we have an obstacle counter, we have the target counter when we move to targets instead of using obstacles. It gives the debug logs. Like all these can be referenced because it's a global static. This static means I can use it from any of my other classes. Then when we go to the shooting that we made on the game, so we have here this game object, bullet instance, fire point position, and fire point rotation. This is the instance for the bullet. We're actually able to program in a variable float speed to see how fast the bullet's going to go. 10 was perfectly fine. We pre-named fire point for a reference that we actually have in our game. I did this fire point as a child of my starship, and I put it 1 meter ahead of the origin, which is 1 meter ahead of the facing direction of the starship. And then we can see where the bullet's actually going is up, so it's the direction up times the bullet speed. So this is where it's going in correlation to like local space of my starship. And we have this being referenced here from an abstract shooter class that gives it the public abstract void shoot, and then we just override it here, and this is what plays the if and statements that we're doing here. I put audio in there so it makes a little repeatable shooting sound. But the game, it's get instant, so as many times as I push the fire button, it'll keep spawning different versions, well, this like copies of the bullet that I'm using, the projectile. And I made it as a prefab in Unity. This is just another way that we use abstraction and inheritance to get our projectile to actually fire. And this will also give us like polymorphism if we made another object that could shoot. This is all going to be used throughout any of the classes that we have, any of the shooters. So if we have an enemy, it can be instanced on that one as well. So where is it? The rotation is what angle the ship is facing, and then the position is where we actually put that fire point, so the 1 meter up. This is how we're going to instantiate every single time it's instance. Every time it comes up into the game, it's going to be put in the same location, but the rotation might change just by based off of where I turn my ship. So if we actually come into Unity to see how that's actually going to work in action, we'll have our starship moving here, so we can have our starship and how it's actually going to be playing. And then when we fire, we can fire at our obstacles here. So you can see here, asteroid took damage. We only have the bullets using 10 as a float variable, but when we come in, And we actually destroyed, we killed the asteroid, it's dead. Kill the other asteroid, it's dead. And now we get a little win condition, so it says we win. If we run into an asteroid, it'll just show that we lose. So we win from the last one, and clear it, show, and now we lose. Starship died. We stop it, we can come into our scripts and put them in folders now so we can actually see how everything's working. And we have death, destroy. See that inherits from our death class, all using inheritance. So death, destroy comes from death. Target death comes from death, destroy. As we can see that we're inheriting all from the previous classes, public override die, destroy game objects, it removes it. And that's the same thing that we're calling here on our death targets. So in the game manager, when our game manager instances the registers a target, so this is actually picking it up on the game manager to see that we have targets to be killed. We have them being referenced here from this void abstract die, and that's what gives our base.die calls to destroy the game object. And then when we come into our actual game manager and we're checking to make sure that we're either adding or subtracting to our final count, we can see our win-lose conditions for target. So target's the death one, removes target when destroyed, win the calls game if the target counter equals 0. So we apply different the obstacles, so I just have asteroids, we'll actually apply the death target to them, and that'll get the register so that they can see who's getting how many of them are left, so it can give us the win or lose condition for the statement. But when we go to our game manager, you can see obstacle count. This plus plus is adding obstacles to that. It adds to the actual counter, and that's what's giving us our reference for adding to. So it can once it references it from the obstacles, and it shows that it's instanced. Then when we come to our game manager, that's what's checking to see if we're either adding more to the scene or if we're subtracting by when we're actually destroying them. And that's going to go the same thing on our death target. Our targets are going to do the same thing. So we can use either obstacles to give us victory, or we can use targets, and that gives us the win-loss condition. So again, we can see here when we're actually winning, if we win, it'll print off the we win. But if we come into and just run into there, we'll get the you lose statement. And for the sound, we added the audio source. And then in the actual shooter bullet script, we can see here, we added this audio play source. One shot allows you to keep pushing the button, and it doesn't cancel out the first iteration, so it can keep playing the sound. And then we have shoot sound and audio source. So this is what's giving us those two variables. We can see here our public audio source and a shoot sound puts them into the actual inspector window. And then so that's where we can come in here. Audio source is the Starship. It just comes out of the Starship, not the actual projectile. And then the shoot sound is a recording I made, and it just gives you that little high-pitched little pew. But I just messed with the audio sources in here, and I was actually able to make it go. My volume was a little lower because it was high, and then the pitch was up. So then that can give us our a little sound here. I thought it was pretty cool, but that was just my little above and beyond for the class requirements. Thank you very much.